Okay, let's begin here. This is Lab 3 for AGEC 410. This replaces our Friday class meeting of the fifth week. Um, we are going to continue with our exercises in policy modeling. We have sort of changed perspectives each time. So if you recall Lab 1, we were thinking about an agent and how they would respond to some something that influenced the price that they see. Then Lab 2, we thought about solving for a market and what happens in the market when to the supply and demand when a tax or subsidy gets introduced. And now, so we went from an agent to a market perspective, and now we're really taking on the sort of pure policy analytic perspective, and some people call it the planner perspective. And that includes, or that allows us to set up these sort of evaluations. Basically, we started these in class the other day of surplus. So look at the market and think about what efficiency gains exist because of the market. The fact that some people are willing to pay a lot and get to pay a low price, some people are willing to sell at a very low price and get to sell at a higher price, all happens because of this sort of collective, this idea that all the transactions and all the information gets known, and so the market settles on one price that will clear it. And so there's all these sort of efficiencies that are gained, these benefits that are gained and allocated among the participants. And so when you start introducing a tax or a subsidy there into that market, you start to bleed out those inefficiencies. And so that's part of what we're going to calculate. So we'll move all the way through to calculating the dead weight loss. But on our way there, we'll calculate how much of the benefit flows to the supply side of the market, how much goes to the demand side of the market, and then of course we'll see what the taxpayer situation is. So let's remember what we did last time. So we had a model, a model of supply and demand over here. We were thinking about linear supply and demand, intercept and slope, and then a market clearing condition, and then this is how we set it up. So we had a market clearing price, but we had two different versions of the price. One that the producer sort of sees their effective price, or the price they respond to, the consumer price that they respond to, and so we modeled those directly, and we had some kind of simple setup here. We'll continue using sort of a simple setup, but we're gonna shift gears and think about the algebraic problem. Okay, so we've spent 2 lectures this week, and we're working through a handout, converting everything to sort of an algebraic representation. And if you recall, we said that the quantity supplied could be written as A plus B times the market price, P, and demand could be written C plus D times P, the market price. So an intercept, a slope, an intercept, a slope, and that we get this sort of basic algebraic solution. P star is equal to the difference in the 2 intercepts divided by the difference in the 2 slopes. And once we account for the fact that D must be negative, we know this will be a positive term here. And so that as supply gets more responsive, B gets larger. As demand gets more responsive, D gets more negative. And so either one of these, supply or demand getting more responsive, drives the denominator here larger and will lower the market price. Okay, and so that's the basic idea. The more elastic you end up, or the more responsive this market gets in total, the lower the market price. Okay, if we step away from that idea of just a market price where we're just solving for the solution, but get back to the idea that taxes and subsidies are the policy instruments of a market, then we have to go back to our idea about the producer price and the consumer price. And again, these are not stated prices. They are derivatives or effective prices. These are the prices that the producer sees and responds to because they know what the tax rates and the subsidy rates are in a market. So you can't withhold that information I mean, you could, but the way we do policy analysis is as though it's been internalized into the decision process. So we give them their effective prices and then replace those or sort of link those to a common market price using what we call price linkage equations. And in this case, the producer price is equal to 1 plus any subsidy or tax that's applied directly to the producer, that agent, the agents on that side of the market. And so this becomes an ad valorem policy measure, converting the market price to the producer's price, their effective price. Here we have the same thing on the consumer side. So a consumer price that they respond to is going to be equal to the market price plus this tax subsidy effect. Both price linkage equations will tie us together back to the market price, so we are finding a market price solution, a market clearing price. And then remember, we said we're setting these two equations, these two price linkage equations up so that when TP or TC is positive or greater than 0, we are talking about a producer or consumer subsidy. When they are negative, less than 0, we are talking about a producer or consumer tax. Okay, so we have this solution back here, C minus A over B minus D. We need a new solution because we no longer have a single price variable, we have 3. So this is no fun. But if you follow through, I think you would see how it works. We have a supply equation here that depends on the producer price. This is the definition of the producer price, so you would just take 1 plus the tax variable times PM and substitute it right there. Same thing here. So the consumer or the demand side, quantity demanded, depends on the consumer price. Take the right hand side here and plug it in, and that's what's been done down here. So A plus B times, right, the replacement for the producer price. C plus D times, this in brackets is the replacement for the consumer price. Sorry. Again, we would collect terms. The market price is what we're trying to solve for. Collect all the terms on one side, and that gives you B plus 1. B times 1 plus TP. Right? That's essentially replacing what was. The B coefficient now is not just B, but it's B times this tax effect, and then minus D times the tax effect is equal to C minus A. If you follow through, however you think about this, I guess I'm multiplying through here. You end up with this, and really what you really need to do, to solve this is we just need to put this in brackets and divide both sides, and that'll give us a solution for PM star. So we have C minus A divided by B plus B times the tax rate minus D plus D times the tax rate. Things to note right away. If the producer tax and the consumer tax are equal to 0, that term goes to 0, that term goes to 0, and we get our normal P star solution. That is our first indication that we might have something that's okay here. The second thing to note from this, whatever the tax influence is in this market, right, a tax applied to the producer side or a subsidy, right, because TP can be tax or subsidy, a subsidy applied or tax applied to the consumer side, it's going to depend on the response on the demand side, the response on the supply side. So this is our first sort of indication that the efficiency in the market is going to be affected here because the taxes or subsidies that get introduced in this market filter into the response. Their effect first looks to say, well, how do suppliers respond to price in this market? How do demanders respond in this market? Okay, so the fact that those get multiplied in is our sort of signal that we are going to have a tax effect into the response, and that response may be that any effects that we produce in the market may be destroying some of the market efficiency. Okay, so I'm going to go ahead and open the spreadsheet. You can too. It's so it'll say class version lab 3. It's the spreadsheet that's given to you. So let's go ahead and fill this in, and if I remember, we're going to just do that same sort of simple setup, and of course I choose it because I can quickly scratch out the solution on paper if I think anything is going wrong. So we'll go with 0 for the intercept of supply, or A, and then for B, the slope of the supply curve, we'll go with 1. And then for the intercept of the demand curve, we'll just go with plus 100, right? So that's an easy value to use. And then we'll just go with minus 1 for the demand slope. Okay, so we're just, the rise over the run of these two curves is plus 1 minus 1. Gives us a pretty simple solution. We know that they should meet up at a price of 50, and if you recall, it'd be a quantity of 50 as well. So first thing to note, the market price filled in. That's because I don't want anyone having to deal with the you can read the slide and see what the formula looks like, and I want you to open this formula and be sure that you see why this is the formula for the price comparing it to the slide we just looked at. But it's pretty easy to get a sign wrong or get a bracket wrong, and I don't want us to spend a lot of time programming this because when you see the handout this week, you can see I want you to get through some experiments and sort of see what you can uncover on what does it mean that B4, right, the supply slope, or B8, the demand slope, is being multiplied by these tax variables. How does that play out when we solve this? So that's already given to you. So we're just going to fill in a little bit of this stuff. Yeah, so we have the market price is being calculated for you. We could keep going and say, well, we know the producer price is going to be equal to 1 plus the producer tax subsidy rate multiplied by PM. Okay, that was our price linkage equation, and that's what goes in that block right there. So 1 plus B17 times B11. Remember, the consumer price linkage equation is a little different. It has a negative sign, so we're going to go with equals, open parentheses, 1 minus the consumer tax subsidy rate, and then we'll multiply that by the market price. Okay. And so we could come down here and put something in, and we should see adjustments, right? We should see that when you put in a tax or subsidy on the consumer side or the producer side, you start to get those things changing, and they do. Okay, but everything's linked through the market price. So PP and PC are determined, relative to the market price. And now we just need the quantity. This is same thing we did last week. You can use the supply or you can use the demand equation, either one. Only thing that matters is be sure you get the right price. So if it's the producer, you need to be sure that they're looking at the quantity supplied, that they look to the producer price. If you use the demand side, you need to make sure they're using the consumer price. And so I'll just use the producer. It's at the top here. So A plus B multiplied by the producer price in B12. So B3 plus B4 times B12 will finish out the quantity of this. And then we could go back down here and think about adding 0.01 again, and now we should stop and see if we're getting what we expect. We said positive is a subsidy. That means we expect the quantity in the market to go up. The producer price is 50.25, the consumer price is 49.75, so they're both getting some benefit here of this expanded market that's been subsidized. Everything looks okay, and if you remember from last week, I think we actually solved that problem and saw that. So let's just check and make sure we got everything correct here. Again, the expansion in the market is the key, right? So this, if you subsidize consumers, right, with a positive, right, TP, TC greater than 0 is a subsidy, so 0.01 is like a 1% subsidy. You expand the market quantity, and then of course consumers benefit. And then of course what's interesting here is 0.01, a 1% subsidy to producers or consumers gives the same exact result for the producer price and the consumer price. Those are the ones we're interested in, right? The market price is just its own thing. It's the balancing force, but really we're interested in what do producers perceive as their price they respond to, and sort of their per unit take on this. And the per unit receipt is this value. The per unit layout or payout consumers is this price. So everything there looks like it's working correct. Okay, we'll switch back. Okay, so here in the slideshow, it looks like I'm just saying we should build a spreadsheet, which we just did. Okay, and then you can see here when I was building this slide, I actually gave myself both columns to work with. So I added a second column. I just copied this column over and said let's run a base case where we do the subsidy on the producer side, and then let's do a check where we do it on the consumer side. You see the quantity effects are the same, producer price the same, consumer price the same. Really the only thing that differs is how does the market price evaluation get adjusted. And in this case, because the producer is the one being subsidized, we think of the market price being pushed down, right? And being the same as the consumer price. We don't have a consumer price effect here, but the market gives them some benefit compared to the no subsidy situation. Same thing here. So when the consumer side is the part that the policy impacts, the producer price and the market price balance out. And again, this price is larger than they would expect if this policy impact was zero. Okay, so it's not just does the policy target you, it's once the policy enters into this market, how does it affect you? Okay, and so one of the things we could think about doing, and you might see suggested in your handout, in your homework that goes with this, is just running this column as a base column and leaving the policies turned off, leaving them at zero, so that you're always evaluating the changes relative to that. Okay, well, we have more stuff to do to build out our spreadsheet. I mentioned at the beginning, the new perspective we're taking is really one that any individual producer or even the sort of industry would never look at and say, this is how we're going to measure how well we're doing, right? They have profit incentives, consumers have budgets, they have savings, they have allocations. But as sort of economists, we've sort of adopted this idea that we can overlay a market and think about sort of economic planning, right? So going all the way back to Adam Smith, who talked about the invisible hand producing this efficiency. Well, after a few hundred years, people have come along and said, well, we can do some math and talk about what the sort of baseline efficiency is. We can say there's sort of a nominal value of surplus that should be achieved if this market is functioning well, and that there's solid competitive effects at work. And so we call those consumer surplus and producer surplus. So it's really an outside sort of perspective of calculating something. So we went through this in lecture, and we got all the way to calculating formulas or equations for consumer surplus and producer surplus. And when I drew it on the board, I told you I think it's easier to calculate and evaluate from the inverse form of supply and demand. And so let's actually just write those equations. So I said let's let the supply equation will now be the price is equal to capital A plus B times the quantity supplied. The demand equation in inverse form is P, or the price, is equal to intercept capital C plus D, the new slope, times quantity demanded. And if you want to relate those back to our previous work, when quantities are on the left-hand side of the equation, so quantity supplied is equal to something, quantity demanded is equal, then that's how you do it. So capital A is really just negative A over B. Capital B is just 1 over B. Capital C is just negative C over D, and then capital D is 1 over D. And really, for purposes of the surplus, we only need capital A and capital C. We need these intercepts, okay, because we're going to calculate those welfare triangles, those surplus triangles, and we need to know how to calculate the height and the base, right? So we'll get the base will come from the market with the quantity, and then the height comes from what's this intercept relative to the price that we are looking at, okay? And so if you remember those formulas, I think I said something like take the market price, subtract A from it, and that gives you the height of the producer surplus triangle. But we don't have that anymore. We don't have a single price. We have a producer price and a consumer price. And we need to use those to calculate our surplus measures, okay, because those are the prices that they respond to, and those are the prices that are going to be in the location where we find the market quantity. So we have some new welfare measures under tax subsidy. These are laid out pretty quickly here. We're going to continue in our lecture series working through all these, so you'll get the development of them. But let's just go with what we have. So producer surplus, consumer surplus, and total surplus. Backing up. If we're going to calculate the surplus measures, we're going to do it relative to, for the producer surplus, relative to this being the price they observe, consumer surplus, this being the price they observe. And then total surplus will still just be add up the producer surplus and the consumer surplus. Now we have a couple other things we want to consider. The taxpayer cost, okay? So the cost of a taxpayer to the taxpayer is positive. It's actual money they spend when we introduce a subsidy, and it'll be negative when it's a tax, because when there's a tax in the market, the taxpayers actually get receipts. They get money to use for whatever public projects taxes go for, okay? If it's positive, that means one of the public projects that's being initiated or being considered or used, Treasury and taxpayer funds are being used for is to supplement this market. Okay, so anyway, to get the taxpayer cost, we just take the difference in what the producer price we see and the consumer price, because that gap will always tell us what the subsidy level is, right? So that gap between those two prices is always going to be the per unit amount that's either spent by taxpayers or received by taxpayers. And if we do the subtraction in this way, we'll get it correctly measured as positive for a subsidy, negative for a tax. Deadweight loss. Deadweight loss you probably calculated as a triangle and did it using a graphical method. Well, we're in a spreadsheet, and of course I am by and large avoiding using graphs as we develop this stuff, and even on the lectures that we do on the board, because I want us to conceptually understand what we're talking about. Okay, I want us to think about this in sort of a quantitative sense. So what is deadweight loss? Well, it's really the idea that let's not evaluate for a moment whether it's a good idea or bad idea to tax or subsidize a market, but let's just think about if we inject, again, it's easier to think about it from a subsidy sense. If we inject some value into a market, we take money out of the treasury or out of taxpayers' pockets, and we're subsidizing this market, then we think it's a public project that either we are correcting a market failure to get more people food, or whatever we're doing, we're pushing that money in there. Well, how effective is it compared to just handing those people money and saying, here is some money? We don't want to interrupt this market. We don't want to affect the sort of balance that happens from getting a pure market solution. And that really becomes the benchmark. And so it's a measure of what kind of surplus gets lost compared to a free competitive market situation. That's what deadweight loss is. It is this idea that money, whether you try to extract it from a market as tax or injected in a market as subsidy gets bled out as the market makes its adjustments. Okay, it's because when you put the money in, you put the full amount in, but it all doesn't turn into sort of either surplus, gain or loss on one side of the market. Okay, so we have 3 steps here that we're going to do, and you'll see I'll move to the spreadsheet right after this. First, calculate the total surplus when there is no tax or subsidy in place. Okay, and to do that, I'm calling it TS prime. So this is sort of the primary, or first best. Some people might call it the first best solution. And to do that, we just need to calculate the area of one triangle. So let's take C minus A, which is that gap between the intercepts of the inverse demand and supply curve, multiply it by Q star, and Q star here is the free market quantity in the market, times 1/2. Okay, because it's a triangle. And so another way to write TS prime might be to take 0.5 multiplied by, to get Q star, the free market quantity, you need A plus B times P star, the free market price, the no tax price. And then again, you're multiplying it by C minus A. And then P star, we know, is actually just the intercepts, the difference in the two normal form intercepts divided by the normal slopes, or the regular slopes. And that's a lot of work, okay? That is, getting TS prime is quite the formula, and you'll see that I've plugged it in for you because I don't want, again, 0.5 times this plus this times all of this times this. I don't want anybody getting frustrated trying to type that in and keep track of the brackets. So if I make a mistake, we all make the same mistake. If I leave that blank and ask you to fill it in, then I'm going to get to look at all of your mistakes because you'll email them to me. So I don't want to do that. And so we'll just go with whatever I have. So don't, if I made a mistake, we'll all just deal with it. I can fix it once if I find a problem with it. Okay, so that gives us this sort of basic total surplus that would exist in the market if we stay out of the picture, right? We are the government. Let's stay out of it and think about what the surplus is. Second, let's calculate the taxpayer cost. And so if it's subsidies, right, that's how much do we spend? How much are we talking about injecting into this market? If it's not that, it's how much do we get out of this market by using this market as our sort of tax basis. And then third, let's compare the total surplus from the market when there is a tax and subsidy compared to a free market, the free market total surplus with the taxpayer cost added. Okay, so think about this. The third step here says calculate the actual total surplus in the market as it exists with taxes and subsidies. Part 1 says give me the total surplus that would happen if we didn't influence this market with a tax or subsidy. The second term here says let's decide how much. Let's think about what the budget is for this, okay? And so we're going to say give me the free market plus the budget, right? Whether it's money coming in as receipts or money being spent as subsidy. And we're going to compare that to the actual total surplus that exists, because if the subsidies we inject into the market don't all find their way to consumer surplus and producer surplus, then we know that that's the bleed from the market. If the taxing case, if we extract money via taxes and we don't get the full tax effect of the lost surplus from producers and consumers, then we know that there was some bleed there. We got less tax dollars, less tax receipts than they actually lost in the market. And that's what deadweight loss is. It's this inefficiency. We're going to keep talking about it. In fact, we are basically going to have an essay question on your midterm that says, explain this term, because that's something that we have to come away with. It is not a triangle. Okay, it was fine to calculate as a triangle through 200 and 300 level classes, but in an ag policy class, we have to understand that this is money, its true value, right, that is being lost through these interventions. Okay, so we talked about sort of incidents already. We've talked about interference in a market and the fact that quantities adjust and people, it's these are interventions. Well, they come with consequences, and that is one of them. Okay, so we'll keep talking about this just a little bit. Why do we calculate the deadweight loss this way and not just the triangle? Well, it's because you can't interfere in a market without getting some sort of efficiency loss, and that's really what we're talking about. So you're going to bleed this off. If you're investing taxpayer funds or collecting taxpayer funds, it's going to be inefficient relative to just a direct transfer. If you have a target that you want to introduce income effect for, it is always preferred to give them what we call a lump sum money, direct transfer. Don't influence the market, just hand them a check. Now, you'll still get some effects in the market, but you will not get this deadweight loss effect. Okay, so our benchmark for deadweight loss becomes this sort of equation right here. Free market surplus, right? What's the market surplus, or how does the market work to create all this sort of efficiency and allocate surplus to producers and consumers? And then what is the direct transfer of treasury dollars? Let's say that we want to invest in producers in this market. We could hand them a check and say, I don't care if you produce or not, right? I'm not trying to influence your production decisions, but here's some money. Okay. And so it becomes the case that only in markets where you think the market failure is specific to the quantity of production can you even make the case of introducing these market interventions. Okay, and so we're really looking for shortfall. We're looking for shortfall on this benchmark, and that's how you're going to see me calculate surplus in this market. So I'm going to switch back. Okay, so you've really gotten my first sort of lecture here on welfare and deadweight loss, and we'll keep working through that. And so our task right now is to finish this spreadsheet out, and then turn you loose with the assignment paper, which is going to ask you to go through and do some experiments. Okay, so the inverse supply value for A, we said we need A and C in here. So as we were going through those slides, it's just equal to negative, don't forget the negative sign, A divided by B. Okay. And then inverse demand C is very similar. It's just equal to the negative. Don't forget this negative sign. It's important. You have to flip. When you invert, you end up with a negative sign there. Negative C divided by D, so that's B7 over B8. Negative B7 over B8. And then negative B3 over B4 is the inverse supply there. Okay. Oops. Negative B7 over B8. So there's a negative sign there. I know it's going to be small on your screen. Okay. And so you should get there, and you get this free market surplus of $2,500. There's no tax. There's no subsidy on either side of the market. You can calculate all this out. 100 minus 0 is 100. Take a half of that's 50. 50 times 50 is the quantity in the market. And then we get down here, and I've already filled in all of these for you. So I have the free market surplus. I've filled in the producer surplus, the consumer surplus. These are the formulas I use if you want to check them, and I encourage you to check everything and see what you think. I calculated the taxpayer cost. Remember, I said I was going to calculate that as the difference between the producer price and the consumer price multiplied by the market quantity. Okay, so we got that one. The total surplus here is just measured as the sum of the producer surplus and consumer surplus is calculated, and then the deadweight loss is calculated down here the way I told you I was going to calculate it. Okay, so let's look at what we have. So I'm taking the free market total surplus first. I'm taking the actual surplus as measured. B27 is the first term here. And so we're taking that to be the actual surplus as measured, and then I'm going to take as the benchmark, subtracted from that in parentheses here, is B23, the free market outcome on surplus, plus whatever the taxpayer cost is. Okay, and so it's probably easier to see how this works when I put in a value for one of the taxes and subsidies. So let's go back and do that. So let's just make a simple 1% subsidy to the producer in this market. And you see the deadweight loss gets calculated here. So the free market solution says 2,500 is the benchmark, or sorry, is what we expect if we don't influence this market. $25, I guess, is the measure of how much money from taxpayers we are injecting into this market. If that gets fully realized as either benefits to consumers or producers, then we get the old surplus measure plus the money we put in from taxpayers. 25 is our benchmark. That's what we expect. Anything short of that is deadweight loss, and you can see right here the actual total surplus calculated in this market comes up just a little bit short, and that's how we calculate the deadweight loss. So I'm taking the deadweight loss here is the shortfall in the new total surplus because we don't fully get the benefit of the $25 of taxpayer money that we injected into this market. This is what bled away, and we can't ever get it back, right? It's because we are working with upward sloping supply, downward sloping demand, and so we influence this market and we don't get the full benefit. Whereas, let's say this really was a subsidy targeted to producers. If you just walked out to all of your producers and said, you know, you were a producer in this market last year, here's a check, here's a check, here's a check. I don't care what you do this year, right? Now it may cause them to invest in their operation and expand supply. It may cause them to change, right? It may change the intercept or the slope of the supply curve, but that's different than, than directly influencing this market. They may just save the money, right? They may just say, well, my income is now the market income plus this check you wrote me. And so those are secondary effects. And so this is all, if you start to understand it, this is all coming around to us working our way back to some of the things we talked about before on how to evaluate policy, thinking about coupled versus decoupled, and what kind of effects we might affect from policy. So one of the ways we do that is think about, is there deadweight loss in the market? How large is it? And thinking about, is there a way to get the benefit, right? So the idea that we're going to inject $25 into this market, it's not really the market. I mean, if it is the market, if it is getting the quantity higher, then that's one thing. And that's maybe the best way we could do it. Maybe it's not. But if it's really just about targeting people that are either on the supply side or the demand side of this market and giving them additional income, then we should think about what alternatives exist that don't allow this, that don't come at a cost, that don't come at this efficiency cost. Okay, so I spent a lot of time talking about this. You'll actually see that when you do your assignment, I'm going to have you more focused on some other things, which is basically comparing these two values. Okay, so really your experiments in your assignment are to help you uncover something a little different than I've spent most of my time lecturing on. So we will cover that as well in class, but hopefully it's something that's a little easier to tease out. And basically, what does it mean that these two values are the same? What is driving that? And of course, the two values that you can find up here that are the same are the slope of the supply curve, the slope of the demand curve. And so we're going to work around that experiment and see if we can come up with, in the assignment, if we can work our way towards that formula. So, yeah, I don't want you to think when you start working through the assignment, well, he spent all this time talking about deadweight loss and efficiency and why we're doing this. Well, this really is your lecture on sort of the bigger picture of welfare, and then of course we'll have another assignment that comes out of this the spreadsheet that we are building up here that focuses more on the efficiency. But first, we need to be able to tie everything back to basic supply and demand, and that's the homework for this time. Okay, I want to shut this off. We're just getting close to what would be a full class period of me talking, and I'll process video and post your assignment for you today.